I would like to thank the organizers and Peter Brook for bringing me here on this workshop. The truth is that I've been working for almost 35 years in interactive music, so I guess I will have some things to tell you. I would also like to thank Professor Ferska for this wonderful crash course on ubiquitous and context-aware interaction. I think if you did not much about that, I think it's hard to say more and better in 1 hour. I would also like to thank him for showcasing our work and by the fact the React table is not by our mutual friend Hiroshi Ishii, but it's from our team in Barcelona. Okay. Okay. So I'm a researcher at the Music Technology Group in Barcelona, and I'm the head of the ICT department at Universitat Pompeu Fabra. As I say, I have been working in interactive music technology for more than 35 years, so I guess this talk will be more wide than deep, but I hope it's not too shallow so that you can still get where we are, and I hope that I can give you a good impression that where we can go. So I will start the presentation with a bit a zoom in, since we are trying to build networks, as Peter said. So we come from a quite young university, which is Pompeu Fabra, which started in 1990, and which is quite urban. It has several campuses with 9 departments, and one of them is the ICT. It's located in all the center of Barcelona, and one of them is the ICT department, in which now I'm of which I'm the director. Also, it's not a too big ICT department. We are kind of very well ranked nowadays. We are the first technology department and in engineering, and one of in the top 100 or 200 engineering studies worldwide, which I think it's good for a university, for a department that has less than 20 years. As I said, it's not that big. We have about 1,000 students and 40 faculty members. I will not comment all the other details. We have a lot of PhD students. We do a lot of research, and we are very active on competitive research. For example, we have now 17 ERC grants, so that's from these 42 people, they have 17 ERC grants, and based on European competitive projects and other type of competitive projects, we get around 10 million euros funding per year. So we are trained in that. Currently, we have 76 projects, and 43 of them ongoing are in Horizon 2020. The research we do in this department is divided in 4 big areas, and each of these areas has different research groups. So we have 19 research groups in 4 areas, and one of them in the multimedia, which I don't like the name because it sounds kind of very old, last century thing, but here we have research on image processing, sound, music, human-computer interaction, and in particular, I'm a researcher in the sound and music computing area, and so I'm zooming in again. So I will talk 2 slides about the Music Technology Group, which is a group that in fact is older than the university. It has 25 years, and we are 4 permanent professors, but with that we have kind of constructed a big infrastructure. Now there are 75 developers, including developers and researchers and postdocs and PhDs. So here are just some numbers. we do what kind of a research group does, but since we are in a university, we also are important on education. So of course we work on the undergrad courses, but we have also a master in sound and music computing and a PhD with many students or many PhDs being part of the group. We don't forget tech transfer. We think that research, we also do kind of a bit, some basic research, but we kind of are conscious about our social impact of our research. So we do a lot of tech transfer, and on the other side, we do a lot of open science, which are two things that are not incompatible. So you can do technology transfer and on the other, and keep things open for the good of everyone. And we do a lot of research. So I would, as I mentioned education, these are some of the technologies that we have transferred. These are some success stories. So that was what Professor Ferska showed on the video. This is the React table. I will talk a little bit more about later. Another success story was Vocaloid, which has had for the last 15 years a huge impact, especially in Japan. In Japan, Vocaloid is a singing voice synthesizer, and in Japan there's a virtual singer that moves millions of fans that doesn't exist, that makes concerts as a hologram, and that uses our singing software. So that has been done for the last 20 years in a collaboration between our group and Yamaha Japan. We have another nice story is Free Sound ORG, which is probably the biggest open database of sounds in the world. So with millions of sounds and hundreds of thousands of users, where people can upload, download sounds. We have many search facilities, and we have APIs that help bringing free sound to different contexts. These are some of the industrial partners we work with, or we have worked along the years. And as I said, we have quite an experience in IC calls. This is since FP4, we have participated in 31 EC projects. Now I'm just talking about the music technology group. Before I was talking about the university, the department, and we have coordinated 12 of them. In this list from 2006, these are the projects that we have participated in. The light blue ones are the ones we have coordinated, and the two darker blue ones, in particular, I was the IP of these two projects. I will talk a little bit about, in particular, Giant Steps later. So our research topics, they change, of course, with the times, but they could be classified along these 4 categories: signal processing, music information retrieval, interaction and musical interfaces, and computational musicology. And this is done by 4 teams or subgroups or labs within the music technology group, one for each of the faculty members that lead the group. So I'm the head of the Music and Multimodal Interaction Lab, and there we work on these things, on music and interaction. And after kind of this zoom-in introduction, I will do a very personal flashback. And I will go back to 81, and I will explain why I've been working on interactive music. Okay, yeah, I changed my glasses. I shaved a little bit. So I was playing tenor sax. I was studying physics. That was 81. And I was playing saxophone. And I was a not that good. I was playing free jazz, and I was a quite bad saxophone player. And I knew that I was not going to be much better because I didn't like to practice, I didn't like to rehearse. I liked to play and to improvise. And in 81, at the physics faculty, one day I discovered a computer. Because I had only seen computers in movies. And there I saw a computer. It was in fact a PET Commodore that professor showed on on his first slide. So I started programming with the PET Commodore, and I had a real epiphany. I discovered that I loved computer programming, but I also discovered that somehow computers are good at doing repetitive things. And once you manage and you know how to tell them how to do things, they do it perfectly. So I thought, I mean, the parts that are, for me, I'm not saying that music practice is boring, but for me, it's not what I was made for. The parts that are repetitive, I will give them to computers. And I will keep the part that I like in music practice. So in 81, which is a bit early, I said, that's what I want to do. And so I started learning, studying at home from the library, picking a few books. That was my first public attempt. Like say, I was a freelance researcher, but I made this paper and I managed to publish it in ICMC in 91. By this time, there was no music technology group, nothing in Barcelona. I mean, in Spain, computer music was a combination that didn't exist. So this program, since I was improviser and I was playing with bands, with free jazz bands and with kind of free rock bands, so I made a software that could listen to two human players and that would respond to them. If you are a bit into computer music, that will remind you of a language that is still in use today, Max, MSP, or Pure Data. Maybe you didn't know that Max MSP, well, not MSP, but that Max existed already in 91. So we have 20 years of Max programming. Since by that time, computers were not able to do audio, we had to rely on specific hardware devices. So that was a computer. It was, in fact, an Apple, I don't remember how it was called, a Mac something, like a box. What? No, it was the smaller one. Okay, but and so there were hardware devices that would convert. I mean, there were commercial hardware devices that would convert audio to MIDI. So the software would work at the symbolic level, and the output would be symbolic and would lead to a synthesizer. The next picture is probably even more hilarious than the first one. This is me with the low-tech Quarticaster in '96. So that is my pre-academic work on interactive music. By 2001, I was kind of the academia. I mean, I was back to university, back to academia. I was doing my PhD, and it was a good time for that. In 2001. There was the first NIME, New Interfaces for Musical Expression workshop in Seattle, and I had the luck of being there. So I will put a little bit the context in this early 2000. The context for interactive music. By that time, we could already see that the record industry was dying, that groups had to play live in order, I mean, we're starting to play live in order to get some to monetize, I mean, to survive. On the other side, electronic music was becoming huge, and however, there were not good devices. I mean, there was always the joke: is this person playing music or reading emails? And this joke has been kept for 2 decades, because there were not, or there are really not direct interfaces for making electronic music. And that's how we conceived, between 2003 and 2005, the React table, which was meant to be a collaborative, tangible instrument meant for different people, meant for different levels of expertise, which is kind of an ideal that has always or often been mentioned in human-computer interaction, especially in the music domain. Can we make instruments with low ceiling, means that everyone can enjoy, and with a low floor, so that everyone can enjoy, and with high ceiling, so that experts don't get bored at. I will come back later. So experts start using it. I mean, we became quite popular when Björk started interacting or using a React table for her Volta tour during 2 years, starting in 2007. I will put another video from a board. What do I have to? So that's from Björk's player. So that's a modular synthesizer which wants to be as powerful as modular synthesizers, but much less scary. It's less scary because the complexity, it starts empty, so the complexity just gets added when you want it. It's a bit intelligent, not that much, but a little bit, because connections, unlike regular modular synthesizers, connections are always correct. Things connect on their proximity, and it was kind of a quite successful thing. I mean, after Björk started performing with it and showing with it, we had a period of time in which we were really quite popular. In fact, by that time we won many awards, and I guess since that we are in Austria, you probably know what this headless Nike is, which is we won a golden Nika, I think it was in 2007, for this work. I mean, in fact, it was so successful that we created a spin-off company, and we made tables for stand-up, I mean, fixed tables and portable tables. One was meant for musicians, DJs, artists, it's portable, and the other for museums and clubs. And it was, I mean, there are many all over the world. There's one in Linz. And it showed that, in fact, it is sometimes possible to do this low floor, high ceiling thing. I don't have all the recipes, but sometimes it's possible. Now I will mix and I will explain when I will talk from the academy or that. I mean, that's a product from the company in which we brought the concept of Reactable into tabletops. Into tablets. We had done it into mobile apps, but here we worked on the possibility of using tangible pucks to control software on an iPad. I will show, I think it's a very nice video. So this is a recording of done on an iPad, and this video uses no presets. I mean, you will learn this music, you will know this music for sure. It uses no presets, it's done live. By one person that has, I mean, skilled on performing that. And what you will see sometimes, like a blur image, is that this person is using the pucks. So there's a combination of hands and pucks. Can you play it, please? So here you see all the modules that do different things, and all the complexity comes from the combination of connecting simple things, like a sequencer, a wave generator, a filter, a delay. So you see the finger, and now it's a puck controlling. That, even if it's just a software for a little, I mean, for a tablet, that in fact is more complicated or the software is more sophisticated than the React table because it came 10 years later. Of course, it's better to touch everything and to have a big surface. So now I will go back into research, and we are now in 2013, when we started a very interesting project, Giant Steps, in which Peter, that was by then at JKU, participated. And the idea of Giant Steps is to bring artificial intelligence into music creation and music making for assisting, especially, expert producers and DJs in producing their music. It was quite a pioneer work at this time, because also there was a long tradition of academic research and experimental art on computer music and algorithmic music. There was very little applied to the commercial world. And we are talking here about electronic dance music. And the consortium was also quite focused. We had Red Bull Music Academy, Native Instruments. So, there were companies that were really there in the scene. So it was a really interesting project. And I will just show two videos. We worked on many things. With my team, we worked more on rhythm, on understanding rhythm perception. How do we perceive rhythm? How can we say that two rhythms are similar? So that's a very simple example of a rhythm space. Here, you have a 2D, I will not get into the technical details. You have a 2D space which has a few dots, and these dots represent, each dot is a rhythmic pattern. So by navigating, we used different machine learning algorithms in order to put these dots there. They were based on user listening tests, many things, and you will see this mouse, this dot, navigating through here, and you will see how the pattern changes in a not continuous, because the events are discrete, but how the pattern creates rhythms that were not originally there. Can you? Oh, okay. Okay, I guess you get the idea. The sound is not very good because we intentionally used kind of a basic general MIDI drum sounds in order to focus more on the kind of structural aspects and not on the timbral aspects. And here I will show a kind of a commercial application of that, which is a simplified application. What you will see in this video is an app for a mobile device, a smartphone app, in which users can create their own patterns, but change them without explicitly saying where I want. I want a bit of that. I want a bit more of hi-hat. So the app puts the hi-hat where it thinks it should be, based on where the other things are and on what the user kind of has asked for. So it's a much more easy to explain and much simpler concept than the one you saw before. Yeah. So here, there's the mode in which the user is explicitly creating patterns. But here, with these sliders, the user can actively modify these patterns or tell the system to modify them. So this was one of the many outcomes of this Giant Steps project that was done in 2016. Oh yeah, it seems that yeah, if I push twice, it goes there. Sorry for. So then I will more briefly talk about another project that we did in parallel, which started 1 year later, which was Rapid Mix. In Rapid Mix, we collaborated with Goldsmith and with IRCAM, with the team of Frederic Bevilacqua, who should be here, but it seems that he will not be here today, no? No. And with companies, with the 7 European companies. And our goal there was to focus on bio and physiosensing. I think in the previous talk, we have seen a lot of the state of the art and applications in this domain. So we focused on bio and physiosensing with creative purposes. And so the goal of the project was kind of to set up the Lego pieces, the APIs, open APIs, hardware platforms that would allow an easy SMEs and independent researchers to work, I mean, especially aimed at the creative industries, to work with and analyze bio and physio data in order to make things easier for them. So we work on EEG, on body movement, and I will show a very simple video of a commercial product that is the previous drum machine that you saw, but now controlled by movement. This is a commercial video. It's a mock-up, okay? Okay. So what I would say, the two projects I have told started one in 2013 and the other in 2014. Now I would say the context has really changed. Giant Steps pioneered some things, but maybe, I don't know if Peter would agree, maybe it was too early. Because today, things are different. Or what has changed? Some has changed dramatically and others quantitative. I mean, some have been more disruptive than others. Although portable devices were already important then, in the last 6-7 years, I mean, they have, as we have seen, I mean, it's an exponential growth, and also the number of applications and with creative purposes. As a bite-side comment, I have to say, there are so many applications for everything. It's extremely nowadays difficult, if not impossible, to survive based on buyers paying for the applications. Other models have to be used because it's very hard with the immense amount of applications that that take birth every day. It's really a hard a market. Obviously, since in the last years, and that's, I guess, why we are all here, the European community has shown an increasing interest in promoting and democratizing creativity. Whatever that, I mean, we have different perspectives of what that can mean, but that is a fact. And that has gone in parallel with increased or a reborn interest in computational creativity in the academia. I mean, computational creativity or artificial creativity applied to music, to images, existed since the 50s. It was big in the 50s and the 60s. It decreased. There have been different waves, and now we are on a big wave. And one of the reasons is a technical reason of something that already existed in the 60s, but that has exploded in the last 5 years, which is the deep learning explosion. Deep learning is not exactly something new, but it has taken all the scientific domains by storm. So it's very hard today to do research without doing deep learning. Why? Because applied research. Because you use deep learning and you get better results, even if you don't understand anything. So everyone is tempted to do deep learning. Deep learning in creativity or in music creativity follows the very trendy wave of artificial image creation. This is the Van Gogh plugin. You learn the network learns Van Gogh, and then you put images, and they get Van Goghized. I have to say, well, I'm not judging the interest of that, and music is much delayed. It's not there. Okay, this is a quite convincing Van Gogh. Music. Also, we have seen examples before of 3 pieces that everyone agreed or thought that they were human composed. I think the flexibility for music creation, we are not there yet. But it's increasing, it's moving very quickly every day. Why? Because it's following the vertiginous progress of all deep learning techniques. Deep learning is not, I mean, music is a very small subset of deep learning applications. But the thing is that all deep learning research, which is, I mean, hundreds of papers every day, can be applied to music. So there are new architectures, approaches that could be tested daily. It's kind of really, many persons would be needed in order to keep updated there. There are many well, not many, but there are important frameworks and APIs available, like Google Magenta, which is specialized on neural networks and other techniques for making music. That these things did not exist a few years ago, and many more papers are published. So that means that really today, research in music computational creativity and intelligent music systems seems more affordable and easier than ever. But, I mean, that has, of course, its pros and its cons. On one side, I would say, I mean, many newcomers, they kind of are a bit, I mean, naive, being naive, not knowing what can be done, or thinking that everything is so simple is not a good thing. And hopefully, I think that still, also the threshold for starting to work on this area has been lowered, which is something really great. I hope still that experience and kind of a perspective still kind of matter. But anyway, it's really, I mean, there are plenty of things that can be done today. This is, I will not, of course, enter into the details, but this is one work we did with a master's student last year, in which we trained a network with loops of drums and bass. I mean, loops that contained just only audio loops contain drum patterns like 1 bar, 2 bar, 4 bar loops with drums and basses. We trained the system with that, and then we gave them drums and they added basses. And the results, I mean, I don't have an example here, and I only have 10 seconds left, so I will skip. So what are our current interests? What would we like to do, and what are we doing right now? On one side, we are going deeper into deep learning. I have my reservations, but the truth is that the results are extremely good. and applied. So we are studying or testing, improving deep learning techniques for helping, assisting, inspiring, boosting human creativity. As we have mostly always done, aiming both at pros and at novices. Also, I think the approaches have to be different. One thing that is clear, we are not into automatic composition. We never want to leave humans out of the loop. We are starting to explore the potential of immersive. Immersive basically would mean virtual reality and gamified music creation. That means converting creation. It's not trivial. I mean, there's always a trade-off with these things. Are you trivializing creation? Are you banalizing? I won't enter into this debate, which I'm perfectly aware of. But on gamifying music creation experiences for the treatment of anxiety and other mental disorders. And we are also a topic that I have not covered today because the time was limited. I have always been interested in collaborative creation, and we are exploring different paths for collaborative music making on mobile devices. So only 2 minutes later, I'm finished. Okay, thank you.